Hi, I'm Jason and welcome to this section of the Pre-Algebra Tutor. Here we're going to switch gears a little bit and talk about multiplying fractions together. A lot of students think that probably multiplication of fractions is really difficult compared to adding or subtracting them because sort of when you think back to, second grade or whenever you learn how to multiply, adding numbers, adding jelly beans, adding toothpicks seem pretty easy, but when you get to multiplication way back when you're young, multiplication at first can seem a little bit weird or difficult if it's not introduced in the right way. So most people think that once you know how to add fractions, then multiplying them must be so much more difficult, and dividing them must be incredibly difficult because long division of numbers is kind of a long process, okay? Well, I'm here to tell you that there's really good news, and I wasn't kidding around. Multiplying fractions together is actually much easier than adding them together or subtracting them. And the main reason is because when you're dealing with addition and subtraction of fractions, you have to find that common denominator. And that common denominator, I hope, from the way I'm showing you to do it, is not a big deal, but it is an extra step. It is something you have to think about, and it's something that's not necessarily, something that might seem easy at first. But when you're dealing with multiplying fractions and later division of fractions, you don't actually have to have any common denominator at all. It's just not even part of the equation. You don't even have to think about finding a common denominator. You don't even have to even worry about it. So really the concept of finding a common denominator really only applies to adding and subtracting fractions. When you get to multiplication of fractions and division of fractions, there is no such thing. You don't even care about common denominator. You just multiply them, and I'm going to show you how to do that here. So what I want to show you is, I could just give you the technique and just show you how to do it, and I will here in a second, but I want you to kind of have an idea of what multiplying by a fraction does. If I ask you, okay, I have a quarter of a pizza, I have a half of a pizza right now. Let's say that's what I have in front of me right now, 1/2 of a pizza, or 1/2 of a peanut butter and jelly sandwich, or 1/2 of a candy bar. It doesn't matter. But imagine a pizza right in front of us here, round pizza, and I have half of it. So I've cut this guy in half, and I have half of it, and the other half is on the counter. Now if I ask you, what is 1/2 of 1/2 of that pizza? In other words, what if I take that half that I actually have right here in my hand and I multiply it by 1/2? In other words, I cut it in half again. That's what I'm doing. When I take something, could be anything, and I multiply it by 1/2, then I'm basically chopping it in half again and throwing away the other half of it, and I'm only keeping half of whatever it was I had to begin with. So if I imagine half of this pizza right here, and I take half of this guy away, then I'm going to cut it in half again, and I'm going to be left with a quarter of a pizza, right? So basically, in terms of words, if you have 1/2 of 1/2 of a pizza, 1/2 of 1/2 of a pizza, then you know by thinking about it here in your head, without any math, you have a quarter of a pizza. Because if I start with a half, and I multiply that thing by a half, I'm only going to have a quarter of this pizza left. I'm going to have this little sliver over here, this 1/4 of this pizza. Now in terms of math, when you start talking about this 1/2 of 1/2 of something, I'll have half of a pizza, that's what I started with, that's the half that I actually had to begin with, but I'm going to multiply this piece that I have by 1/2. Which means I'm basically taking what I had, which is a half of the pizza, and I'm multiplying by a half. I'm cutting it in half again. That's what I'm doing. So you can think of when you multiply by a fraction, you're really chopping down the original number that you had. What if I had 4 jelly beans? 4 jelly beans in my hand, and I want to take half of that away. I multiply by a half. And you know that if you have 4 jelly beans and I take half of them away, I'm only going to have 2 left. I've chopped it in half. That fraction, think of it as a hatchet. It's kind of chop, chop, chop. That's all it's doing. When you multiply by a fraction, it's chopping down the original number you had. Well here, I only had a half to begin with, so when I chop it in half again, I'm going to have less than the half I started with. I'm going to have that 1/4. So the way you multiply these fractions is very simple. There's no common denominator. I mean, these happen to be the same, but it has nothing to do with anything. They don't have to be the same. All you do is you multiply the numerators, so 1 times 1, and you multiply the denominators, 2 times 2. You don't have to find a common denominator. You don't have to worry about any of that. You just multiply it. So on the top, you're going to have 1 times 1 is 1, 2 times 2 is 4, and that's the answer, 1/4. And that's exactly what we did with our thought experiment, just thinking about it. If I have half of a pizza and I chop it in half, I'm going to have 1/4 left over, and this is the reason why. because you're basically cut it in half again. And so you're multiplying the top, you multiply the bottom. That's it. Now let's take another example. What if I want to say the following? 1/2 of 2 pizzas is 1 pizza. Now let me ask you a question. Would you agree with this statement? 1/2 of 2 pizzas is 1 pizza. Well, I think all of us could agree with that. If I have 2 pizzas here, right, that's what I start with, and I multiply by half, in other words, I take half of them away, then all I'm going to really be left with is one of these pizzas. If I take 1/2 of what I have here and sort of throw the other half away, I'm only going to have one left over. Now in terms of fractions, what you have here is 2 pizzas that I started with multiplied by 1/2. But don't be scared off by this, because 2 can always be written as 2/1. Any whole number can always be written as 2/1 because this is just division here. 2 divided by 1 is 2, right? And so what I'm going to have here is multiplied by 1/2. And so when I do that, what I'm going to have here, 2 times 1 is 2. 1 times 2 is 2. So I have 2/2. Now what is 2 divided by 2? It's just 1. That's the answer. So I have 1 pizza. So I have proven with fractions that it sort of makes sense based on what you think about. If I have 2 pizzas and I multiply by 1/2, I'm only going to have 1. 2 pizzas multiplied by 1/2, I'm only going to get 1. Half of a pizza multiplied by 1/2, I'm going to have 1/4. So this fraction in both cases is really chopping down the original amount that I had based on whatever the value of that fraction is. But to do it mathematically, all you're doing is multiplying the numerators, multiplying the denominators, simplifying the result. You don't worry about common denominators for fraction multiplication. You definitely don't worry about them for division. That's why I say they're easier. There are less steps involved. So you should be happy about that. It's going to save you a lot of time. So let's go ahead and do another one, and we'll just kind of go through these, and you'll see that it's really not that hard. What about 3/4 multiplied by 5/7? So if you were adding these things, you would say, well, there's no common denominator here. I've got to get that common denominator. I've got to deal with all that. But when you're multiplying, you don't have to worry about that at all. 3 times 5 is 15. 4 times 7 is 28. 15/28, and that is the answer. You try to simplify the result, but effectively that is basically the answer. So you see how easy it is compared to adding them. What about 2/5 multiplied by 1/7? Well, 2 times 1 in the numerator is 2. 5 times 7 is 35. 5 times 7 is 35. So 2/35. 2/35. Multiply the top, multiply the bottom, try to simplify the result. What if we have something like 3/7 multiplied by 6/5? Again, don't even look at common denominators. It doesn't matter. 6 times 3 is 18. 7 times 5 is 35. 18/35. Try to simplify the result. In this case, it doesn't. What about 2/9 times 4/5? 2 times 4 gives me 8. 9 times 5 gives me 45. Can't really do anything to simplify that. Can't divide by 2, can't divide by 5, and so on. What about negative 4/9 multiplied by 1/2? Don't worry about the fact that it's negative. That isn't going to affect anything. Whenever well, it is going to affect the problem, but you don't really need to worry too much about it. When you're multiplying these guys, remember I told you this negative can float on the top or the bottom of this fraction. The only thing you need to do is pick one. In other words, don't apply the negative here and here. You need to pick that it's going to be on the top or the bottom. So I'm going to pick it on the top. Negative 4 times 1 is negative 4. 9 times 2 is 18. Okay, so negative 4 over 18. Now I can simplify this because I can divide this by 2 and I can divide this by 2. So the answer will be negative 2, 4 divided by 2 is 2, over 9. The final answer, this negative can be moved right out in the front. Negative 2/9. Negative 2/9. Really simple. Multiplying fractions is actually really, really nice. Not really a problem. What about 6/7 multiplied by negative 2/9? thirds. Now the only reason I write it in parentheses here is just because when you have a negative sign, when you have a multiplication symbol right next to a negative symbol, you might accidentally think you're subtracting these things because it's just a dot here. So sometimes you see it wrapped in parentheses, but it's no big deal. It's not really any harder at all because what you have here is you multiply the top. 6 times 2 is 12, but I'm going to keep this negative up here. I'm going to call it negative 12. You need to figure out where this negative is going to float and choose one path and stick with it. 7 times 3 is 21. So you're going to have 12 over 21. Now you can divide the top of this guy by 3, and the bottom you can divide by 3 to give you negative 4. 12 divided by 3 is 4. 21 divided by 3 is 7, and I can take the negative sign out, 4 sevenths. Negative 4 sevenths. What if I had 5 sixths multiplied by negative 3 tenths? 5 sixths multiplied by negative 3 tenths. Same kind of thing. 5 times 3 is 15, but I'm going to keep this negative up in the top, so I'll keep it as negative 15. 6 times 10 gives me 60. And so that's the answer, but I know that I can simplify it. I can divide this by 15, and I can divide this by 15. So it would be negative 1 on the top. 60 divided by 15 is going to give me 4. And so we can take this negative out, negative 1/4. Negative 1/4. All right. What if we have something a little bit different? What about 1/2 multiplied by 2.5? So this looks a little bit complicated at first until you realize that you can just convert this to an improper fraction, and it's really easy. So 1/2 multiplied by, how do you convert this? 2 times 2 is 4, plus 1 is 5. 5 halves, because you always write it over 2. Now it's the same exact problem. This denominator happens to be the same, but that has nothing to do with it. It doesn't matter at all. 1 times 5 is 5. 2 times 2 is 4. Now this is the answer, but that's an improper fraction, so you want to try to convert it if you can. How many times can 4 go into 5? It can go 1 time. 1 times 4 gives me 4, so the remainder is going to be 5 minus 4 is 1, and write it as 1 over 4. So we have 1 and 1/4. So yeah, multiplying fractions is quite simple. I'm going to show you something here in just a minute that's going to make it even easier in some cases. What if you have 4 3/5 multiplied by 2/3? Okay, so I always recommend that you convert these fractions. Multiplied by 2/3. Okay, 2/3. What is 23 times 2? 23 times 2 is 46. What is 5 times 3? It's 15. So you have 46 over 15. Now this is an ugly improper fraction. How many times can 15 go into 46? Well, 15 times 2 is 30. 15 times 3 is 45. So it can go 3 times with a remainder of 1. And I'm going to write it as 1 over 15. 3 and 1/15. Now here in this one here, I'm going to show you something interesting here. What if you have, so pay attention really carefully to this. What if you have 3 2/5 times 5/4? So we're going to follow the same exact process. 5 times 3 is 15, plus 2 is 17 over 5, multiplied by 5/4. So I'm going to show you 2 ways to do this problem. The first way, from this point forward, is exactly what we've done up until now. So pay attention here. 17 times 5. When you put that in a calculator and figure that out, it's going to give you 85. 5 times 4 is 20. So you have 20. Now this is an improper fraction. How many times can 20 go into 85? Well, 20, 40, 60, 80. It can go 4 times. So 4. So 20, 40, 60, 80. So that's a remainder of 5. 5/20ths, because I always have to write it over this. But I can actually simplify this even more. I can divide by 5, and I can divide by 5. So the final answer here would be 4 and 1/4, because 5 divided by 5 is 1, 20 divided by 5 is 4. So this is the answer. So this is exactly what we've been doing before. We convert to improper, multiply the top, multiply the bottom, convert back, simplify, we're done. 4 and 4 1/4. But notice that as you get higher and higher with fraction multiplication, it just becomes ugly because you have, like here we did 17 times 5. What if this fraction were, 10 2/5? then this top number would be really big, and you'd be multiplying really large numbers, and then you'd be simplifying the answer, chopping it back down to something more reasonable like we did here. Now let me kind of peel off and show you. Let's take it sort of from this step, because we converted the fractions to improper. Let's take it from this step, and I'm going to show you, it's not really a trick, it's just something you're going to need to know. 17 over 5 multiplied by 5/4. So again, the way we did that way, we just multiplied top and bottom, simplified. You can always do that, always, always. But notice that these guys are multiplied together, and I have a 5 in the top and a 5 in the bottom. And remember, I told you that with a fraction, you can multiply or divide a fraction by anything you want, as long as you do it to the top and the bottom at the same time. So over here, when we simplify 5/20ths, what we're doing is dividing by 5 so that we get a simpler answer. Here, what I can do, basically, since this is a giant fraction that's sort of multiplied together and you're going to get a big fraction in the end, anytime you see something on the top and the bottom, it could be even on a different fraction, if they're multiplied together, this only applies if they're multiplied together. If I see something like this, common, or even something that I might be able to simplify, I can do it. So what I can do is 5 divided by 5 is 1, 5 divided by 5 is 1. So I've simplified it before I've even done the multiplication. Make sure you understand that. Because I've got something that's a sort of like a common multiple in the top and the bottom, I can take the top of this giant fraction and divide it by 5, giving me 1, and I can take this part and I can divide it by 5, giving me 1. But I've got to divide the top and the bottom by the same thing. That's really what you're doing here. So you're doing exactly what we've been doing over here, dividing the top and the bottom by a fraction by the same number. It's just that here the fraction is split apart and it's not really even multiplied yet. So if I see something common to the top and the bottom like this, I can simplify it even before I do the multiplication. I can divide this by 5, giving me 1. I can divide this by 5, giving me 1. Okay, so why would I even do that? Because now this 5 is not even there anymore. This 5 is not even there anymore. The 1s are now here. So 17 times 1 is 17. 1 times 4 is 4. So you say, well, what answer is that? But if I look at this, I say, well, this is an improper fraction. How many times will 4 go into 17? 4 times 4 is 16. So it's going to go 4 times with a remainder of 1 over the 4. I get exactly the same answer as I did before, but notice how much easier it was. Here, I had to multiply 17 times 5 to get 85, 5 times 4 to give me 20. Then I had to convert to improper, and then I had to simplify it again. Here, right as I got to the point where I was just about to multiply the fractions, I noticed I had a 5 up here and I had a 5 down here. So if I divide the top of this fraction by 5, I'll change this to a 1. If I divide the bottom of this fraction by 5, I will change this to a 1. That will totally simplify the multiplication, because now instead of 17 times 5, I'll do 17 times 1. And I'll do 1 times 4. That makes for much more manageable multiplication. It's going to be much easier. And like I said, if this problem, instead of 3 2/5, what if it were like 10 2/5? Then this number would be huge, and the multiplication and the simplification would just be ugly. So if you can do some simplification beforehand, before you multiply, it's basically going to be a lot easier for you to do. Now, I could talk about this one over and over and over again, but I really think you'll see it better if we just work a few more. So let's do that now. What if I had negative 5/16 multiplied by negative 2 4/5. So I have two fractions, both negative, multiplied by one another. This one is a mixed fraction, so I'm going to go ahead and convert this to a improper fraction. So I have negative 5/16 multiplied by negative 2 times 5 is 10. 10 plus 4 is 14 over 5. Now you see where we're at. If I actually solve this problem the other way, I would have to take 5 times 14, and then I would get a number, and then I would have to take 16 times 5, and then I would get a number, and I would have a very large numerator and a very large denominator, and then I would have to simplify the whole thing. I'd be basically dividing by stuff to try to simplify that. But here, I look at this, and what I'm going to actually do is I'm going to actually rewrite this whole line right down here. Negative, I'm going to write it very large. 16 multiplied by negative 14 over 5. because I want you to be able to see what I'm doing. So I notice I've got two 5s here, so I can basically cancel those out right away. 5 divided by 5 is 1. 5 divided by 5 is 1. So I'm dividing the top and the bottom of basically this whole giant thing by 5. So I'm done. I've got this taken care of and I've got that taken care of. But I also notice that I've got a 14 here and a 16 here. And I know that I can divide both of those by 2, and that will make it simpler also. So if I've already done this part, so forget about that. That's done. That part is done. Now, separately, if I take 14, divide by 2, I will get 7. If I take 16, divide by 2, I will get 8. So it looks a little bit ugly, but basically I've changed this 5 into a 1, I've changed the 14 into a 7, I've changed the 5 into a 1, and I've changed the 16 to an 8. And you might think, well, that's a whole lot of work just to save a few steps, but really it's much easier because now, remember, 1 times 7 gives me 7. 8 times 1 gives me 8. It's a negative times a negative, that gives me a positive fraction, so this is positive, that's the answer, 7/8. 7/8 is the answer. Now I can guarantee you 5 times 14 is going to give you a big number. 16 times 5 is going to give you a big number. You're going to have big numbers on the top and the bottom, and you'll be able to simplify the answer, but you've got such big numbers, it's going to take you a little bit longer to simplify that. You're doing the same thing here, except you're doing it ahead of time, and it makes it easier because you haven't really multiplied anything yet. You can kind of look anywhere you want, top and bottom. If you can see something to simplify it, you can. And I encourage you to use a quick little strikeout and change the numbers. That'll help you keep things straight. So let's keep going. And like I said, I really do think that you'll get the hang of it as we work a few more problems. What if we have 4 1/5 multiplied by negative 10 over 21. Negative 10 over 21. So this is obviously needs to be converted to improper. So 4 times 5 is 20, plus 1 is 21 over 5, multiplied by negative 10 over 21. So I notice, again, right away, if I do this the normal way, 21 times 10 is going to be 210 in the numerator. 5 times 21 is going to be a very large number in the denominator, and then I'll have to deal with simplifying that really big fraction, which is not really easy. You can do it, you can keep dividing and dividing, but it just takes you a little bit longer. Here I notice right away, I've got a 21 and a 21, so I can divide the top by 21, that's going to give me a 1 here. I can divide the bottom by 21, that's going to give me a 1 here. I have to do it by the top and the bottom. In other words, I have to find a pair that I can deal with. Divide this by 21, divide this by 21. Okay, I'm done with that. Now, 5 and 10, I can divide top and bottom by 5. Divide this bottom by 5, that gives me 1. Divide the top by 5, that's going to give me 2. 10 divided by 5 is 2. So I've done all of it. Now, 1 times 2 is 2. 1 times 1 is 1. Don't forget you have a negative. Negative times positive is negative. 2 over 1 is just 2, so you have negative 2. Negative 2 is the answer. And again, you could have done the multiplication and figured it all out. It just would take you more steps. So and the other thing I want you to get in the hang of doing this, because when we get into algebra expressions with variables and letters on the top and the bottom of fractions, you're going to be doing this a lot. You're going to be looking for things on the top and the bottom that you can sort of cancel out. This is what you're really doing here. So get used to doing it with your fractions. It'll help you in the long run. All right, what if we had 5 2/5 multiplied by 5/9? So let's convert this guy to an improper fraction. 5 times 5 is 25, plus 2 is 27/5 multiplied by, and this is just 5/9. So there we go. We can take 27 times 5 and get the numerator, and then 9 times 5 and get the denominator, and we could simplify that answer. But we notice right away that we have a 5 and a 5, so I can divide this by 5, give me 1. I can divide this by 5, give me 1. Furthermore, I also notice that 27 and 9 play nicely together. I can divide this by 9, give me 1. I can divide this by 9, give me 3. 27 divided by 9 gives me 3. And now the fraction is very simple. 3 times 1 is 3. 1 times 1 is 1. 3 divided by 1 is 3. Trust me, once you get the hang of this, this is so much faster than doing all this multiplication and simplification. Now you're not going to be able to do this all the time. You have to have pairs in the top and the bottom that play nicely together. but when you have the opportunity, take it, because it'll help you. All right, what if we have 11/20 multiplied by 1 and 3 20-seconds. 1 and 3 20-seconds. So let's convert this to improper. We're going to have 11/20 multiplied by 22 times 1 is 22, plus 3 gives me 25, over the denominator, which is 22. Now I look at this, and I'm confronted with the same thing. 11 times 25 is going to be a huge number on the top. 20 times 22 would be a huge number on the bottom, and then I would spend all afternoon trying to simplify it. But if I look ahead of time a little bit, I say, okay, this plays nicely together. I can divide both of these by 5. 25 divided by 5 gives me 5. 20 divided by 5 gives me 4. Okay, I'm done with that. Now, 11 and 22 also play nice. 11 divided by 11 is 1. 22 divided by 11 is 2. So I'm dividing these guys by 11. I'm dividing these guys by 5. And I've basically done all the simplification ahead of time. 1 times 5 gives me 5. 4 times 2 gives me 8. 5/8. Trust me, it's a lot easier doing that than it is doing this giant multiplication and then trying to simplify the answer. All right, what if you have 5/6 multiplied by 7? So don't get worried too much about that. You look at this and you might think, well, this is totally different. Well, actually 5/6 is really multiplied by 7 over 1, just like from before. So we can do this and look at it and try to simplify it. Do we have anything here that we can divide by? Well, we have 5 and 1 and 6 and 7. There's really nothing that I can divide by top and bottom that's going to simplify that fraction. So we don't simplify it anymore. We just multiply. 5 times 7 is 35 over 6 times 1 is 6. And so we have an improper fraction. How many times will 6 go into 35? 6 times 5 is 30. 6 times 6 is 36. So it can only go 5 times, giving me 30. The remainder will be 5 over 6. 5 and 5/6. And just like we've harped on before, if you have a fraction with a variable in it, don't treat it any differently. You need to use the same rules that we've been using. They're no different. X is just a number. You don't know what it is. Could be 5, could be 17. So we look around and we say, well, I can just multiply these, sure, but I notice I have 2 and 4. I can divide the top by 2, giving me 1. Divide this by 2, giving me 2. And so I can sort of pre-simplify. And so x times 1 is going to give me x. 2 times 5 is going to give me 10. So I have x over 10. This is a fraction. Whatever x is, it's going to be in the answer. So just leave it like that. There's nothing else you can do with it. What if you have y over 6 multiplied by 3 over 5? Same thing. I could go ahead and do the multiplication here, but I notice that I have 3 and 6, and they play nice. 3 divided by 3 is 1. 6 divided by 3 is 2. Y times 1 is y. 2 times 5 is 10. Y over 10. So I just do a little bit of simplification. I could have done the multiplication first and then simplified, but you know, if you see the opportunity, take it. M over 7 multiplied by n over 2. There's nothing I can do here as far as simplifying ahead of time, but m times n is just going to be m times n. And there's nothing special about it. 7 times 2 is going to give me 14. There's nothing I can simplify. I have no idea what m and n are, so I just leave that as the answer. What if I have a over 4 times 2b, which is just 2 times b in the numerator here, divided by 5. So I multiply the top, I multiply the bottom. There's a couple different ways I can do it. Let's just multiply. A times 2b is just going to be 2 times a times b in the top. 4 times 5 is going to give me 20. So I have 2ab over 20. Now that is the answer, but remember, I can divide anything I want by the top and the bottom. So 2 divided by 2 is going to give me 1. 20 divided by 2 is going to give me 10. So really all you're going to have at the end is a times b over 10. Now it's going to take you some getting used to realize that it's legal to do this. You only learn it through watching. So here we had 2 times a times b. A and b are just along for the ride. They're multiplied, they just stay there. When I divide the top by 2, then a and b just stick around. There's nothing that really happens to them. You're just dividing the number. 2 divided by 2 is 1. 20 divided by 2 is 10, so that's going to be the answer. And we're going to get into more simplification of expressions as we go along in the course, but I'm trying to give you a little bit of practice with it ahead of time. Let me give you couple more really quick examples just to reinforce order of operations. What about 2/3 minus 1/3 times 2/5? So here you have a subtraction and a multiplication. Think back to order of operations. What do you do first? There's no parentheses or anything, so really you always do multiplication before you do any subtraction. So you're going to deal with this first. So 2/3 minus. Now let's do the multiplication. 1 times 2 is 2. 3 times 5 is 15. This minus stays there because it's always going to be there. You're just subtracting off what we have computed here. We're sticking it right here. Now we're doing a subtraction. So now we have to look at common denominator because we're doing a subtraction. So I can take this 2/3 and I can subtract 2/15. And to get this common denominator of 15, which is what I'm going to shoot for, I can multiply by 5 in the top and the bottom. 2 times 5 is 10 over 15 minus what I had over here, 2 over 15. 10, and then the denominator is just going to be 15 because now it's common. 10 minus 2 is going to give me 8. 10 minus 2 is going to be 8. So 8 over 15, that's the answer. One more, just to reinforce order of operations. What if I have 1/8 plus 3/4 times 1/2? Again, what do you do first? Do I add the 1/8 plus the 3/4 first? Or do I do the multiplication first? Well, I'm always going to deal with multiplication before addition if they're on the same line like this. So 1/8 plus, now what do I have here? 1 times 3 is 3. 4 times 2 is 8. Now I have fraction addition and the denominators are already the same. So the denominator will be 8. 1 plus 3 is 4. So I have 4/8. I can divide the top by 4 and I can divide the bottom by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. 1/2. 1/2 is the answer. So always double check your order of operations. Make sure you're doing things in the right order. Multiplication takes priority over addition, subtraction. Parentheses take priority over all of it, but I didn't have any parentheses in that problem. So that is fraction multiplication. I think you'll probably agree after doing it that it's not as, and I don't want to say addition and subtraction of fractions is difficult, but certainly multiplying them is easier. It's just less steps to do. The main thing that we need to remember is when we're multiplying fractions, you don't care about a common denominator. You just multiply the tops, multiply the bottoms, simplify the result. That's fine. Now, if you start getting into larger fractions, then you're going to have the opportunity to simplify the fraction ahead of time. And if you have that opportunity, go ahead and take it.